Hello, Nafisa.
Hello, sir.
Hello, how are you?
I'm fine, sir. How are you?
I'm good. Okay, so Matthew and Nafisa, so today we will discuss the prism,
Okay,
refraction
sir.
through prism. So this is a prism, you can say this is one surface and this is the another surface. This is a triangular prism. So this is the one surface and here on the opposite side, it is like this. Here is one surface and here is another surface. Okay. So this is the one refracting surface, not reflecting. This is one refracting surface, okay, and this is the another refracting surface. Refracting surface, and this is known as the angle of prism. This angle A. What is A? A is the angle of prism. Angle of prism. So when you will see this prism from the front side, so this will look like a triangle only. When you will look this prism from a front side, so it will look like a triangle. So we will draw prism like this, okay? But in actual, the prism is this. This is the front view. Front view. And what is the angle of the prism here? A is the angle of prism here. Triangular prism. Okay. Now, what is prism? Basically, prism is a solid, homogeneous, or transparent refractive medium, and this is bounded by two surfaces. One surface is this, another surface is this. Bounded by two surfaces, two plane surfaces, you can say. And these two surfaces are inclined to some angle known as the prism. So you can write about the prism a little bit. A prism is solid, homogeneous, transparent, and refracting medium. And refracting medium bounded by two plane surfaces, two plane surfaces inclined at an angle, okay, inclined at some angle. So these are the two surfaces. One surface is this, another surface is this. Okay, two surfaces. One surface is this, another surface is this. These are also surfaces. This is also a surface, but we are talking about this and surface. This is the front view. This is the front view of the prism. Now we will drive for the angle of the prism. We will drive for the angle of prism, and we will see the refraction through prism. Okay, we will see the refraction through the prism. So this is a prism. So this prism is basically made up of glass. This is the angle of the prism. Okay, Matthew, is my voice okay na, Nafisa?
Yeah, sir, it's fine.
Yes, sir.
Now see, here is air. Around the prism is air. Around the prism is air. Now, light is coming like this. Suppose light is coming like this. Suppose the light is coming like this. Okay, this is the incident ray. So light is coming from air. Light is coming from air and entering to the glass. This prism is made up of glass. Glass prism, basically, you can say. Means the material glass as compared to the air will be the denser medium. So this ray is going from rarer medium to the denser medium. So what we will do, we will draw a normal on this surface. Okay, suppose this surface is the first surface. Okay, this surface is the first surface and this surface is the second surface. So now this time the refraction is taking place through first surface. So normal, we will draw the normal. So we can draw easily normal. What is normal? So you can say this is the normal, suppose. This is the normal. So normal means this line will make the angle of 90 degree with this surface. So normal. So as the light ray is going from rarer medium to denser medium, it will bend towards the normal. I have told you many times. It will bend towards the normal like this or like this. Okay, so the ray will bend towards the normal. So if there is no refraction, then this ray should go like this. Should go like this now. If there is no refraction. Okay. So this is the path of the ray when there is no prism present. But due to the prism, this ray either going in this direction is going in this direction, means this ray is getting deviated. This ray is getting deviated. Okay. Now this ray now this time is in the glass. Now it is going from glass to air. Now on the second surface, the refraction will take place. So we will draw a normal again. So normal will be like this. This will be the normal. So now you can see here the light ray is going from denser to rarer. It will bend away from the normal. So this light ray will bend away from the normal like this. Okay. So this light ray will bend away from the normal. So now you can see here, this is the light ray. Okay. Initially, this is the incident ray. This is the incident ray. And this is known as the emergent ray. Emergent ray, this is just emerging out from the prism. If there is no prism, then this ray should go like this. But what is the path of the ray after emerging from the prism? This is the path of the ray. If you want to find the angle of deviation, before that, suppose this is the normal now. This is the normal. So we can just take out some of the angle. So the angle made by the incident ray with the normal is the suppose angle I. Angle of incidence. Now this is the refracted ray for this surface. This is the refracted ray. Suppose this angle is R1. Suppose this angle is R1. And now again, this is the incident angle as this is normal. For this ray, this is the incident angle, this angle of. So this is R2 suppose. And this angle is the angle of refraction and this is known as the angle E, angle of emergence, Okay. So what is I? I is the angle of incidence. What is E? angle of emergence. Basically, this angle of emergence is also the angle of refraction, but we say in case of the prism, this is the angle of emergence. Okay. So now just produce the finally refracted ray in the backward direction like this. I have just produced this ray in the backward direction. So this will be looking like this. And now you can see here, this is the path of the ray when there is no prism. And what is the actual path of the ray? This is the actual path of the ray. And when you will produce this ray in this backward, so this is the deviation in the ray. And this is the angle of deviation. This is the angle of deviation. Okay. After this, see, this is the incident ray direction. Whole direction is the incident ray. This angle is I angle. This angle is I angle. So this whole angle will also be angle of incidence. This whole angle will also be I, vertically opposite angle, vertically opposite angle. So if this whole angle is I, if this whole angle is I, so what will be this angle? What will be this angle? What will be this angle? This will be I minus R1. Okay. Similarly, this whole angle will be angle E, vertically opposite angle. So what will be this angle? So this angle will be E minus, this total angle is E minus R2. Okay, so you can say it will be E minus R2. E minus R2. Now see this triangle, this, okay, wait. Okay, so see this triangle, this triangle, this triangle. If you will see this triangle, for this triangle, this angle is the exterior angle, and this angle I minus R1 and E minus R2 are the interior angle. And when we were driving the mirrors formula, I have told you in a triangle, exterior angle is equal to the sum of opposite interior angle. So exterior angle, this del, we can write this del is equal to This del is equal to sum of this and this. So I can write I minus R1 plus E minus R2. Del is equal to I minus R1 plus E minus R2. So we can write del is equal to, from here I can write I plus E minus R1 plus R2. I plus E, I will take minus common and I can write R1 plus R2. Suppose this is equation number 1. You have to remember for this triangle, this triangle, I am given the name to this triangle. This is O, this is A, and this is P. So you can write in triangle, here you can write in triangle OAB, OAB. Okay, now it's fine. Okay, now what I am doing, this is one normal and this is another normal. Suppose this is N1 and this is normal N2. Okay, I am producing these normal, or I am extrapolating these normal, you can say, or just you can say producing the normal. So it will be like this. These normal will meet here. Now suppose this point is as point P, where both the normals are meeting. Both the normals are meeting. Okay, now focus here. See the quadrilateral. Quadrilateral means like triangle. Triangle have 3 sides. Quadrilateral have 4 sides. Triangle have 3 sides. Quadrilateral have 4 sides. So why I am saying quadrilateral? Suppose this point is Q. This point is Q. So now see the quadrilateral. See this quadrilateral. A, Q, B, P. Focus on the quadrilateral A, Q, B, P. So you can write in quadrilateral A, Q, B, P. Quadrilateral like rectangle is a quadrilateral. Square is a quadrilateral. Rhombus is a quadrilateral. Parallelogram is a quadrilateral. These are the quadrilateral. Sum of all the interior angles of a quadrilateral we know is 360 degree. If you take a rectangle, suppose this is a rectangle, so this angle will be 90 degree. This angle will also be 90 degree. This angle will also be 90 degree. This angle will also be 90 degree. So in a quadrilateral, no matter the angle is 90 or whatever, always the sum of all the interior angles of a quadrilateral will be equal to 90 degree. So here also for this quadrilateral, the sum of the interior angle should be 90 degree. Okay, so before that, see this triangle APB. See triangle ABP, or you can say APB, no problem. We can find this angle. This angle will be 180 minus R1 plus R2. Is it or not? Because in a triangle we know we are studying the geometrical optics. So here we are using geometry. So this is geometry. So this is a triangle. So in this triangle, this angle and this angle is given. And what is the sum of all the angles of a triangle? 180 degree. To find this angle, you will subtract R1 plus R2 from the 180 degree. So this angle will be 180 minus R1 plus R2. Okay. Now, see this angle. This angle will be 90 degree because this is the normal, and this angle will also be 90 degree. This angle will also be 90 degree because this is the normal. Now, angle Q, angle A, angle P plus angle B is equal to 360 degree. You can write angle A plus angle B plus angle P plus angle Q must be equal to 360 degree because this is a quadrilateral. So what is angle A? This angle A is 90 degree. This angle A is 90 degree. So angle A is 90 degree. Angle B is 90 degree. So this angle B is 90 degree because this is normal. Angle P. Angle P is this 180 plus this is 180 minus R1 plus R2 plus angle Q. Angle Q is angle A. Angle Q is given as A. So this is A and this whole is equal to 360 degree. Now 90 plus 90 is equal to 180. This 90 and this 90 is 180 and 180 and 180 is 360. So this 360 will be cancelled out with this 360. So you will get A is equal to R1 plus R2. A is equal to R1 plus R2 you will get. Suppose this is equation number 2. Now put the value of R1 plus R2 here. So you will have del is equal to I plus E minus A. So this is your del or the angle of deviation. This will be the angle of deviation. Angle of deviation. Okay, what I have done here in this equation, instead of this R1 plus R2, I have put R1 plus R2 is equal to A. So I have got this. Okay, take the screenshots. Done?
Yes, sir.
Okay.
Yes, sir. Done.
So remember this formula. Deviation is equal to angle of incidence plus angle of emergence minus angle of prism. A is the angle of prism. Del is equal to I plus E minus A. And this relation also you should know. A is equal to R1 plus R2. Okay, now we will solve one numerical on the same. So we have one prism here. This is a prism. And this prism is equilateral prism. It is given that this prism is the equilateral prism. Equilateral prism. And there is a ray of light like this. This is a ray of light, incident ray, and this is normal. And with this normal, this ray of light is making an angle of 60 degree. And this is the equilateral prism. So they are asking, find E. What is E? Angle of emergence. This angle. Angle of emergence. And they are saying, find the deviation. Angle of deviation. Del is known as the angle of deviation. I have written here. Angle of deviation del. Okay. So this condition is given. This is the equilateral prism given. We have to find the angle of emergence and we have to find the angle of deviation. See how we will find now. This ray of light will suffer deviation like this. Means this ray of light, here is air, okay, and here is also air. So this is the light ray will refracted towards the normal. Okay, this is the normal. So if this is the angle 60 degree and this is the angle of incidence, okay, this is the angle of incidence I. So this will be the angle of refraction. Suppose this is R1, okay. So this is the first surface. Suppose this is the second surface. Suppose incident ray. This incident ray is refracted. Now here also the refraction will take place as the medium changes. So normal will be there. We will draw normal. This is the normal. So here also the light ray will bend away from the normal. Why the light ray will away from the normal? Because this light ray is going from denser to rarer medium. And one more thing given, this is the equilateral prism, and one more thing for the prism is given. Refractive index of the prism given, that is √3. Mu of the prism is √3. Okay. And angle of emergence is this angle. This is the normal. This is the angle of emergence. The angle of the emergent ray with the normal is the angle of emergence. Okay, so from here the light will reflect like this, and we will draw one normal here. This is the normal, and from here the light will be refracted like this away from the normal. Okay, and this angle is the angle of emergence, and this is the R1, and suppose this is R2. This angle is R2. And as this prism is equilateral prism, so this angle will also be 6. This angle will be 60 degree. This angle will also be 60 degree. And this angle will be the angle of prism. So you can say that angle of prism is given as 60 degree. And one more thing is given, refractive index of the prism is √3 is given. Okay, we want to find this angle. So we have assumed this is the first surface and this is the second surface. So now we will apply the Snell's law We will apply the Snell's law on the first surface. On the first surface, we will apply the Snell's law. So I have told you how to apply the Snell's law. Here is air and here is refractive index √3, a medium of refractive index √3. So we will apply the Snell's law on first surface. Snell's law, which surface? First surface. In the last class, I have told you how to apply the Snell's law. Choose any medium. So suppose air medium you have chosen. So write the refractive index of the air. Refractive index of the air multiplied by sine of angle with normal. What is the sine of angle with normal? Sine 60 is equal to for another medium. What is the another medium? Glass is the another medium. So refractive index of prism you can say, and multiplied by sine of angle with normal. So what is the sine of angle with normal? R1. So it will be R1. Okay, and A is representing here air and P is representing here prism. Now refractive index of air we know is 1. The refractive index of air is equal to 1. We already know. Multiplied by sine 60. Sine 60 is √3 divided by 2. Now refractive index of prism. This is the refractive index of prism. √3 multiplied by sine of R1. Sine of R1. Now this √3 and √3 will be cancelled out. So you will have sine of R1 is equal to 1 by 2. Sine of R1 is equal to 1 by 2. So this 1 by 2 you can write as sine 30 degree. So R1 you will have 30 degree. R1 you will have 30 degree. Now you know the relation. Now you know one relation. Angle of prism is equal to R1 plus R2. Let's see here. Angle of prism is equal to R1 and R1. So remember this also. And what is R1? R1 is this angle and R2 is this angle. So angle of prism is 60 degree. So put here 60 degree. What is R1? R1 is 30. Now put R1 is 30 here. Plus R2. So from here you will get R2 60 minus 30. R2 you will get again 30 degree. So this angle R2 you will get 30 degree. Okay. So R2 you will get 30 degree. Now apply the Snell's law on the second surface or second interface. Second surface. So choose any medium. So light is going from here to here. You can choose any of the medium. So take the refractive index of this medium, that is √3. Now I am applying directly, multiplied by sine of angle with normal. Sine of angle with normal. This is normal. And what is the angle with normal of the incident ray? R2. So sine R2. And this is equal to refractive index of other medium. Other medium is air. So refractive index will be 1 multiplied by sine of angle with normal. What is the sine of angle with normal? E. Sine E. This is √3 and this is sine of R2. What is R2? R2 is 30 degree. So it will be sine 30 degree is equal to 1 into sine E. So 1 into sine E can be written as only sine E. So this is √3 and this is 1 by sine 30 is 1 by 2. This is equal to sine of E. So sine of E you will get √3 by 2 and √3 by 2 can be written as sine 60. So you will write sine E is equal to sine 60. So angle of emergence, you will get 60 degree. Okay, angle of emergence, you get 60 degree. After that, they are saying find the deviation del. Del is equal to I plus E minus A. What is angle of incidence? 60 degree. And what is angle of emergence? That is also 60 degree. So you write 60 degree. What is angle of prism? Again 60 degree. So angle of deviation, you will get 60 degree. Okay, take the screenshot.
Done.
Done. Okay. Done.
Yes, sir.
Okay.
Yes, sir. Done.
Okay. Now we will see. We know that angle of deviation del is equal to angle of incidence plus angle of emergence minus angle of prism. So we will see on which factors the angle of deviation is depending. On which factors the angle of deviation is depending. So basically this is experimental analysis. Factors on which angle of deviation is del. Depends. Number one, refractive index of the prism. If the refractive index of the prism increase, the angle of deviation will increase. And this is all experimental analysis. So if you will increase the refractive index of the prism, mu of prism will increase, then the angle of deviation will also increase. This arrow is representing in upward direction, so this is representing increase. Number second, angle of prism. So angle of prism is, we know angle of prism is A. A is the angle of prism we have defined. So now you can say the angle of deviation is equal to angle of incidence plus angle of emergence minus angle of prism. So from this relation, it is looking like that if you will increase the value of A, if you will increase the value of A, the angle of deviation will decrease. For example, suppose del 1 is I plus E minus 30 degree. So here you have taken the angle of prism 30 degree. Now suppose you have increased the angle of prism to 60 degree. Now you have calculated del 2 I plus E minus 60 degree. So if I plus E is same, then which value will be greater? Which value should be greater? This del 1 should be greater na? Means on increasing the angle of prism, and here del 2 should be less. So angle of deviation is decreasing. But experimentally it is found that when you will increase the angle of prism, then angle of deviation will also increase. Another factor on which the angle of deviation depends, the wavelength of the light. Wavelength of light. Wavelength of light is lambda. So if the wavelength of the light will increase, then refractive index will decrease. We know that the refractive index is inversely proportional to the wavelength. So if wavelength will increase, refractive index will decrease. So the angle of deviation should also decrease. Okay. So the angle of deviation should also decrease. We have na Vibgyor. Violet, indigo, blue, green, yellow, orange, red. When you are going in this direction, so wavelength increases, na? Lambda increases. So when you will go in this direction, so the angle of deviation will decrease. So for the violet light, the angle of deviation is greater as compared to the angle of deviation for the red light. Now there is a graph between the angle of deviation and the angle of incidence. Angle of deviation and the angle of incidence. That can be asked in your exam also. On this y-axis, there is angle of deviation. Here, there is the angle of incidence. So this graph is like this. Something like this, okay? So at this point, the angle of deviation is minimum. So here is the angle of deviation is the minimum. Okay, angle of deviation is minimum. And this graph is not a parabolic graph. This graph is not a parabolic graph. Not a parabolic graph. So it is not symmetric. Okay. Suppose you have chosen any other angle of deviation, suppose del 1. So for this angle of deviation, there will be one angle of incidence here, that is suppose I1, and there is another angle of incidence also, that will be here somewhere. This is I2. And this is the angle of incidence for which the angle of deviation is minimum. And when this happens, when the angle of incidence for which the angle of deviation becomes minimum, this angle of incidence also equal to the angle of emergence. For example, if you have a prism like this, this is a prism, okay, and this is the incident light. Suppose this is the incident light, and this incident light will suffer refraction like this. It will go like this, okay. So you will draw the normal here. This will be the normal on this surface. This will be the normal. So this is the angle of incidence. For example, the angle of incidence I is equal to 30 degree. For example, we are talking about the example. I am explaining what is this. If angle of incidence is 30 degree, and this is that angle of incidence for which the angle of deviation for this ray of light is the minimum, then this angle of emergence will also equal to 30 degree. And here in this case, the angle of deviation will be minimum. What is the angle of deviation? This is the angle of deviation, okay. This is the angle of deviation, del minimum. And one more thing here, this angle R1 and this angle R2. As now you can see from the symmetry, this angle is 30 degrees, so this angle is R1, this is 30 degrees, this is R2. So you can say that this R1 and R2 are also equal. The angle R1 and R2 are also equal. So this R1 is also equal to R2 when angle of deviation is equal to minimum. So what are the conditions when the angle of deviation is minimum? In that case, the angle of incidence becomes equal to the angle of emergence, and R1 and R2 are equal. So you can write here angle of deviation is minimum for one value of angle of incidence, for one value of angle of incidence. Now you can see here the del is becoming minimum. So here there is only one value of angle of incidence, and for any other angle of deviation, there are two value of angle of incidence. Okay. If suppose this del will be not del minimum, so this angle will be different, this angle will be different. Okay. Okay, so you can just write down. Take the screenshots.
Done.
Done. Okay.
Yes, sir. Done. Yes, sir. Done.
Okay. So when angle of deviation is minimum, means angle of deviation is equal to minimum angle of deviation. So in that case, angle of incidence is also equal to the angle of emergence, and R1 is also equal to R2. Okay. So now we will prove one more thing. We will calculate the refractive index of the prism in terms of the angle of minimum angle of deviation. Suppose this is the ray of light is going like this, and after refraction, this ray will go like this, and again there will be the refraction, so this ray will go like this, and here is the normal, this is the normal, this is the normal. Okay, so this is the angle of incidence, this is the angle of incidence I. We know that when uh, the angle of deviation is minimum, so this angle of incidence and angle of emergence both are equal. So suppose this is also I, suppose this is also I, and this is suppose R, this is R1, and this is R1. So R1 and R2 both are equal. Okay, yeah. So you will take this as R and this also as R, because R1 and R2 are equal. So we know that there is a relation that angle of the prism, this is the angle of the prism for this prism, is equal to R1 plus R2. So you can consider this R1 plus R2 is equal to R, because both are equal. So R1 is also R, R2 is also R. So you can write A is equal to 2R. A is equal to 2R. So from here you can write R is equal to A by 2. This is equation number 1. And we also know that angle of deviation for a prism is equal to angle of incidence plus angle of emergence minus angle of prism. But here angle of incidence is equal to angle of emergence. Okay, so you can write del is equal to, this becomes 2I minus A, this becomes 2I minus A. So from here we can find I. Okay, from here we can find I. So how we will find I? It will become del. And one more thing here. This is the condition where your this del becomes the del minimum. Okay, this will become del minimum. Why? Because I is equal to if angle of incidence is equal to angle of emergence, then del will be del minimum. This is del, okay, not S. So del minimum is equal to this value. Okay. Now from here find out the angle of incidence. So angle of incidence will be del minimum plus A is equal to 2I. So from here you can find the angle of incidence is equal to A plus del minimum divided by 2. Okay, and suppose mu is the refractive index of the prism. Okay, mu is the refractive index of prism. And here around it is air. Here also air. The refractive index of the air is 1. Okay, and mu of the prism is equal to, suppose, mu. Okay, so on this surface, we will apply the Snell's law. This is surface first. This is surface first, and this is the incident ray. Okay, this is the incident ray. And this is the reflected ray. And this reflected ray again becomes the incident ray, and again it will be refracted. So we will apply the Snell's law on first surface. Apply Snell's law for first surface. So this is the first surface, and what is Snell's law? Refractive index of one medium multiplied by sine of angle with normal is equal to refractive index of another medium multiplied by sine of angle with normal. So here, this is the air medium. So what is the refractive index of this medium? 1. So you will multiply refractive index of air multiplied by sine of angle with normal. Sine of angle with normal is sine I. Another medium is prism, medium of the prism. So you will write mu p multiplied by sine r is equal to, this is equal to mu of p into sine of r. Now refractive index of the air is equal to 1, and refractive index of the prism is mu. So this is 1, and here you will put sine value of I. What is the value of I? A plus del minimum by 2. A plus del of minimum divided by 2. Mu p is mu. Okay, mu p is mu. And sine of r. Sine of, what is r? R we have find it out in terms of the angle of prism. That is a by 2. R is equal to a by 2. We will put here. R is equal to a by 2. Now from here we can find the angle of, means the refractive index of the prism. That will be equal to sine of a plus del of minimum divided by 2 divided by sine of a by 2. So that's how you can find out the refractive index of the prism. And this is valid when, this formula is valid when both sides there is air. Mu is the refractive index of prism, and A is the angle of prism. Del minimum is the minimum angle of deviation. Minimum angle of deviation. Sine is sine. Okay, note down.
Yes, sir, done. Yes, sir, done.
Okay, so now in this from this formula means suppose a prism is given and the angle of the prism is given to you and the minimum angle of deviation for that prism will be given, suppose, and they can ask you the refractive index of the medium. And in your 12th class, I think there is one experiment also. When I was in 12th, I have done, I think, this experiment where we have to find the minimum angle of deviation, or I think we have to find the angle of means the refractive index of the. I think it is there. So right now I do not know whether it is or not in your lab. So by the way, if numerical will come, so you can solve with the help of this formula. They will give you the minimum angle of deviation and they will give you the angle of prism. Then you can find out easily the refractive index of the prism. Okay. After this, we will see the refraction through the spherical surfaces. Till now, we have seen the refraction through the plane surfaces. Hmm? Plane surfaces, now we have seen like water surface is also the plane surface. Glass slab is also the plane surface. Prism surface is also the plane surface. Now we will see the refraction through spherical surfaces. Refraction through spherical surfaces we will see. Refraction from spherical surfaces. Refraction from spherical surfaces. So we will get this formula n2 by v minus n1 by n2 by v minus n1 by u is equal to n2 minus n1 divided by r. I will tell you what are all these things. Okay, suppose there is a spherical surface. There is a spherical surface. This is not the spherical surface. Suppose there is a spherical surface like this. This type of, I think. This is a spherical surface. Okay. This is a spherical surface. And this is the principal axis, and this principal axis here, this is the pole. This is pole. This is principal axis for this spherical surface, and this is the pole. And suppose somewhere here the object is placed. Here the object is there. Okay, this is the object. Object is placed, and here is the center of curvature. If there is a spherical surface, so spherical surface is a part of the sphere, so there will be the center of curvature also. So this is the center of curvature, and we know that the distance between the pole and the center of curvature is known as the radius of curvature. So this distance will be the radius of curvature, this distance. And remember, in this case, all the distances we will measure in, not in this case, in throughout the optics, we will measure all the distances from pole. So all distances, earlier also we have discussed this, all distances measure from pole. And one more thing, the distance measured in the direction of incident light is positive, otherwise negative. Distance measured in the direction of incident light is positive, otherwise negative. Otherwise means opposite to the direction of incident light will be negative. Okay. Okay. So suppose this is the object, so this object will give the ray of light. Suppose from this object the ray of light is like this on this spherical surface. And one more thing, here is another medium and here is another medium. So here is the medium of refractive index N1 and here is the medium of refractive index N2. So this surface means here there is some different medium and here there is some different medium, and this have the refractive index N1, and this surface and this medium has the refractive index of N2. Suppose at this point M, this is the incident ray. Okay, so we know that the ray is just going from one medium to another medium. One medium to another medium. So what happens when the ray goes from one medium to another medium? Refraction takes place. So we will draw the normal to define the direction of incident ray, the refracted ray. Suppose this is the, so normal we know will pass from the center of curvature. Normal will pass from the center of curvature in case of the spherical surfaces. So this is the normal. So normal will pass from the center of curvature because of this spherical surface. So normal of spherical surface passes from the center of curvature. So for example, suppose this is the rarer medium and this is the denser medium. For example, so if the light ray is going from rarer to denser medium, it will bend towards the normal. So this is the normal. So suppose this light ray is going like this. This light ray is going like this, suppose. Okay. And suppose this angle is θ1. Angle of incidence this time I have supposed as θ1, and suppose this angle is as θ2. This angle is as θ2. This is θ1. Now from this object another ray is like this. So whenever a ray is normal to the surface, so this ray is going normal to the surface. Okay, so it will pass straight. It will pass straight. There will be no refraction. There will be no refraction when the ray uh, is like this. You can see here. In this case, now I have told you, if a ray is going straight like this, then it will pass straight. There will be no refraction. So here also the ray is just going straight, and you can say parallel to the perpendicular to this surface. Okay, so it is going like this, not suffering any refraction. This is going like this. But the medium is changing here, but then also it is not undergoing any refraction. So it will go like this, and finally it will meet the here with the refracted ray. So here will be the image. Okay, this is the image I, because two rays are just meeting here. These rays are just meeting actually, so this will be the real image. So here is the image. Now just draw a perpendicular from this point to this point. So this perpendicular is suppose P dash. This is the perpendicular to the principal axis from point M, P dash. Now this OP distance is the object distance. OP distance is the object distance. This OP distance you can mark as object distance U. This is U, object distance. And where is the image formed? Here is the image is formed. So this distance you can mark as the image distance V. Okay, this is the image distance. And this PC is the radius of curvature. So from pole to the center of curvature, the distance is the radius of curvature. So from pole to the center of curvature, the distance will be the radius of curvature. Okay. Okay. Few more assumptions we have to take. Suppose this angle as alpha in this triangle, this angle is alpha, and this angle as beta, and this angle as gamma. Alpha, and this angle is beta, and this angle is gamma. So in this triangle, see in this triangle OM, this point is M. Okay, this point is M point. This point is M point. So in triangle OMC, in triangle OMC, see this angle θ1 is the exterior angle. In triangle OMC, this θ1 is the exterior angle, and alpha and beta are the interior angle. So we can write exterior angle is equal to the sum of the opposite interior angle. So theta 1 can be written as alpha plus beta. So theta 1 is equal to alpha plus beta. Now see this triangle CMI. See the triangle CMI. So in triangle CMI, see this triangle CMI. So this beta is the exterior angle here, and theta 2 and gamma are the interior angle. So we can write beta is equal to theta 2 plus gamma. Beta is equal to theta 2 plus gamma. So from here you can find theta 2. Theta 2 is equal to beta minus gamma. Now find tan alpha. Find tan alpha. So tan alpha will be before that assumption we have to take. We will take some assumption. Rays are paraxial. If the rays are paraxial means these rays are very close to the principal axis. So this alpha, theta, beta, gamma, all these angles are very small. So you can say alpha, beta, gamma, theta 1 and theta 2 are very small. Very small. And one more thing, if these rays are paraxial, na, so this P will be just close to P dash. So P will be just close to P dash. So you can say that this P dash is tending to P. If P dash is tending to P, so you can write OP is equal to OP dash. So OP can be written as OP dash and CP can be written as CP dash. And IP can be written as IP dash. IP can be written as IP dash. Tan alpha. Now find tan alpha. So from this triangle we can find tan alpha. So tan alpha will be MP dash divided by OP dash. Tan alpha is equal to MP dash divided by OP dash. And OP dash can be written as OP. So you can write. So just let's assume this height as h, MP dash as h. So it will be h divided by OP dash as OP. And what is OP? OP is the U, object distance. And this object distance you will take negative. Why you are taking this negative? Because the incident ray is in this direction and you will measure the distance, object distance in this direction. So you will take this as h upon minus. Now tan beta, or you can say tan beta. Find the value of tan beta. So tan beta will be h divided by CP dash. H divided by CP dash, and CP dash can be written as CP. So you can write this as H divided by R. Now C, CP is equal to R. This CP distance is equal to R. So why I have taken this this distance, this R as positive? Because from the pole you will measure the distance, no? So means you will go in this direction to measure this PC distance. So you are going in the direction of the incident ray. That is this. That is why this R will be taken as positive. Now tan gamma. Tan gamma can be find out with this triangle M P dash into I. So tan gamma is equal to H divided by IP dash. Tan gamma H divided by IP dash. And IP dash can be written as IP. And what is IP? this IP is equal to image distance, and image distance also we will take positive, because to measure the image distance we have to move in this direction from the pole. Okay, and this is also the direction of the incident light. So we will take B as positive. So H by V. Now we will use these as assumptions. We know that tan alpha can be written as alpha, because alpha, beta, gamma are very, very small. So from here you can write tan alpha can be approximately equal to alpha. So alpha is equal to H upon minus U. So similarly you can say beta is equal to H upon R. Similarly you can say gamma is equal to H upon V. Why this is happening? Because this alpha, beta, gamma are very, very small. So 10 in terms of tan alpha, I can write alpha only. In terms of tan beta, I can write beta only. In terms of tan gamma, I can write gamma only. So we have now alpha, beta, gamma. Alpha, beta, gamma we have. Okay. So now for this surface, for this refraction from this surface, apply the Snell's law. Apply the Snell's law. So how you will apply the Snell's law? Refractive index multiplied by sine theta means n1 sine theta 1 is equal to n2 sine theta 2. Okay. Now theta 1 and theta 2 are also very small angles. So you can write sine theta 1 equal to approximately equal to theta 1, and sine of theta 2 approximately equal to theta 2. So this will become n1 into theta 1 is equal to n2 into theta 2. Now see what is theta 1 from here. Theta 1 is alpha plus beta. So alpha plus beta is equal to n2. What is theta 2? Theta 2 is beta minus gamma. Theta 2 is beta minus gamma. So you will put beta minus gamma. So this is n1. Now put alpha. What is alpha? Alpha is h upon minus u. Alpha is h upon minus u plus put beta. Beta is h by r. So beta is h divided by r is equal to n2. So what is beta? Here also you will put beta. Beta is equal to h by r. So it will be h by r minus what is gamma? Gamma is h by v. Gamma is h by v. And now h and h and h will be cancel out. This h cancel out. Okay, you will take h common and it will be cancel out. So you here it will be minus of n1 by u plus of n1 by r is equal to n2 by r minus of n2 by v. Okay, so now this n2 by v will come this side, so it will become n2 by v minus n1 by u. This is equal to n2 by r, and this n1 by u will come this side. Oh, sorry, n1 by r. N1 by r will come this side. So it will be minus n1 by r. Okay, so we can write n2 by v minus n1 by u is equal to r will be taken as LCM. So you can write n2 minus n1 divided by r. So this is the final formula you will get for refraction from the spherical surfaces. Refraction from the spherical surfaces. And what you have to remember, you know what is n2 and n1. So n2 is the refractive index of medium in which light is going. N1 is the refractive index of medium from which light is coming. And what is V? V is the image distance just I am leaving the class, please wait. And U is the object distance. U is the object distance. R is the radius of curvature. And in this formula, all the values you will put with sign. Okay, so this thing you know very well. All the values you will put with sign. And remember, all the distance will be measured from the pole. Okay, please take the screenshots, all of you. So this derivation is little bit same as that of derivation we have done for the mirror formula. There also we have these kinds of assumptions. Okay, take the screenshot. So in the next class, we will take some of the numerical on this. So this in this derivation, basically, what is the name of the chapter? Geometrical optics, na? So geometrical optics means you have to use geometry with optics. So optics means this is the light and we are using the geometry also.
Yes, sir. Done.
Done.